All right, we are going to talk about how old those fossils really are. So determining the age of fossils using a technique called radioactive dating. So the way we know the history of the Earth, the way we know how and what types of organisms lived way long time ago before humans existed or recorded history existed, is we use these things called fossils. And you guys should know what fossils are from elementary school. But this is a technique called radioactive dating. So fossils are solidified remains or imprints of once living organisms. So you can actually see fossils that exist here in Colorado. I don't know if you've ever been to Dinosaur Ridge in Golden, but there are actual Triceratops footprints that you can find there. And those help prove, obviously, the existence of Triceratops or dinosaurs. The older a fossil is, the further down the rock layer it is. So basically, the older it is, the more further it's buried. It's buried deeper and deeper. Organisms that resemble the living creatures of today are mostly found of the top layers. So all of the layers, the top layers of the rocks, okay, all the rock layers that are closest to the surface are going to have fossils of organisms that look very similar to today's organisms, whereas the ones that are really far down towards the bottom are going to be the ones that are more ancestral, okay, the ones that are way long time ago, maybe don't resemble some of the things that we see today as much. And I'll let you take a look at some of these examples. So we don't really have guys that look like this. We do have guys that look like this. But you'll notice that you've seen probably all these different types of seashells and crabs that exist, and these are probably a little less common, and these ones down here are a lot less common. So these would be your oldest ones. So most fossils are found in sedimentary rock, and you guys learned about the different types of rocks when you were in elementary school, but they are mostly found in sedimentary rock, but they can be found in lots of different types of substrates or rocks. So since it's in sedimentary rock, and you remember that sedimentary rock is created when rock is broken down into very fine particles like sand or mud and then hardens. So what type of conditions do you think fossils could best be created at? So I want you to think about that and write your answer in your interactive notebook really quick. All right. Whoa, did you know that most organisms that have ever lived, 99% are extinct? So think of all the organisms that are currently alive here on Earth. That is only 1% of the organisms that have ever survived on Earth. And so fossils provide this historical sequence known as the geologic time scale. The geologic time scale we're going to go into a little bit more as we continue to study, but I do want to give you a brief overview of what that looks like. Okay, so we'll wait for that to load. In the meantime, we'll come back to that. We can estimate the age of a fossil using radioactive dating. This is probably a new word for you, radioactive dating. So rocks contain radioactive elements or chemicals that break down. Okay, the half-life is the amount of time it takes for half of the chemicals in the rock to decay or turn into another chemical. So in other words, a half-life is a test to see how long it takes for half of the chemical that exists in a fossil to disappear or to become something else. So we can analyze a sample of the radioactive chemical from a rock found near the fossil and calculate its half-life to estimate how old the fossil really is. We're going to practice doing this if this still seems a little confusing to you. So different chemicals have different half-lives. For our example, we are going to use carbon-14. So carbon is an element, and 14 is a type of carbon, so carbon-14. So if I look right here, carbon-14 has a half-life of 5,700 years. So in other words, if I have a certain amount of carbon-14, after 5,700 years, only half of that carbon-14 would still be in existence. Okay. Another example is uranium. Okay, uranium is another element we look for, and uranium has a longer half-life. It has a half-life of 713 million years. So we would have a certain amount of uranium, and then we would have to wait 713 million years, and then we would have half that amount of uranium. Thorium is 13.9 billion years, and we would have half of that. Plutonium, 2.4 million years, and we would have half of that. That is essentially what a half-life is. So carbon-14 is the radioactive element, meaning that it is an unstable substance, meaning it decays, it falls apart, but it falls apart at a very regular pace. So as carbon-14 decays, the atoms change to another more stable element called nitrogen-14. So when carbon leaves the element or leaves the substance, it turns into this nitrogen-14. And nitrogen is way more stable and it will stick around. It doesn't have a half-life. It's not radioactive. It takes about 5,700 years for half of the radioactive atoms in a sample of carbon-14 to change to nitrogen. This period of time is known as the half-life of carbon-14. Again, all I'm saying there is that it takes 5,700 years for half of the carbon-14 in a substance to decay or turn into nitrogen-14. After 5,700 years, I only have half the carbon-14 I started with. All right. So all living things contain carbon-14. That's why we use it to date fossils, because they were living things. And plants take in carbon dioxide during photosynthesis. You should remember that part. And therefore, we also take in carbon-14. So when plants take in carbon dioxide, when they're breathing in, they take in a form of carbon called carbon-14. When animals eat the plants, we also get carbon-14 in our body. And so do the animals that eat that. When a plant or animal dies, they are no longer taking in carbon. That makes sense. They're not eating or breathing anymore. The carbon within it begins to change or decay to nitrogen. So immediately when that animal dies, we are able to begin the clock for the half-life. After a while, most of the carbon-14 will decay into nitrogen-14. So during life, we keep gaining carbon-14, gaining it because we're eating or we're breathing or whatever the case may be. And then after death, immediately we start losing that carbon-14. So this is an activity you are going to actually do tomorrow in class. But first I want to all right. All right, so here is the geologic time scale. So Earth was created 13.8 billion years ago. That's when the Big Bang is supposed to have happened. And as we go like this, you'll notice that, and I can put this link on my website so you can check it out. But as I drag this arrow, it tells exactly what is happening. So the Big Bang has the beginning of time, space, matter, energy. And as I keep going, these are all the elements of the periodic table that are being created. And it keeps going and it keeps going. Light is being created. Okay, so you'll notice that all the elements have been created that we know of. And now the sun ignites. So the sun is about 4 billion, almost 5 billion years old. Okay, and our solar system takes place. So we start, so here's the Earth right here. Okay, 4.6 billion years ago. Okay, we start our different eras on Earth. So the moon collides with the Earth. The Earth forms a solid crust. We get oceans forming, we get cells forming, we get different organisms forming. Earth's atmosphere stabilizes. All these different things happen, and there are different eras. So it's really cool to play with this and kind of look at all the different things that happen within these different eras and look at the time, the amount of time distance in the past that all this stuff is happening. So for example, the cells happened, the first cell was formed almost 3.8 billion years ago. And it took that long, 3.8 billion years, for it to evolve into us. So evolution is a slow process. Understand that. But yeah, this is the geologic time scale. And again, I'll put that on my website so that you can check it out and kind of play with it a little bit more. But I do want you to understand how radioactive dating happens. And like I said, we're going to do an activity on this tomorrow. So if you're not still quite sure, understand we will do something. So yeah, write down any questions you have, and thanks.